On this question, it was a multiple response question, lots of different answers there. The best start to figure out which one this matches with would be to simplify this, okay? To simplify this, this is a power to a power, so I would multiply the exponents, right? Can't see. Oh, you want to pull the board? Okay. So multiplying these exponents, I end up getting p to the negative 6 over 5. Now, I know we don't normally leave it with a negative exponent, but you know it's going to be the same thing. It's just going to be on the bottom of a fraction. I'm going to leave it like that right now. This seems like a pretty easy thing to compare to, right? All right, so let's look at the first multiple choice option. The first multiple choice option has p in the radical, and is that it was p to the negative 6 like this, and a 5 here, right? Well, remember that this number here will end up going to the top of the fraction in an exponent rule, right? This will go to the bottom, which means that this would simplify to the same thing. It would be to p to the negative 6 over 5. Does that make sense?
Yeah.
So that one does match up. The next one that they give you has 1 over the square root of p to the 15. Now, putting it on the bottom there, you would have the negative exponent here would make this go to the bottom of a fraction. So I wouldn't automatically eliminate there. However, this exponent here is a 15, which is going to be the top part. This is a negative 6, not matching up right there. This would be a negative 15 if we put it up there. This right here, since there's no number, it's understood to be a what?
1.
Normally I'd say yeah, but this is the root. This is square root, so this is going to be a 2 normally. All right, so even though it's not written there, it's understood to be a 2. So this would be the same as p to the negative 15 over 2, which definitely doesn't match up with that one. All right. The next multiple choice option has 1 over p to the 30, okay, which is just p to the negative 30, which definitely doesn't match up.
Yeah.
We're not multiplying these two exponents, so that wouldn't fit. That's where it stays there. All right, the next option we have the fifth root of p to the negative 13. The fifth root p to the negative 13, which again, this one would be the top of the fraction, this one would be the bottom. So this would end up being p to the negative 13 over 5, which doesn't match up, does it? It's for...
Mr. Funk,
Yes?
wouldn't the denominator, which would be the 13, go on the bottom? Because the denominator goes on the bottom, right?
The 13, the one that's on the variable itself underneath the radical, does go to the top. Just like this went to the top. That's why this one matched. Because this does equal p to the negative 6 over 5.
I thought the denominator was...
Think about it, if you do the square root of x, that is the same as saying x to the 1/2, right? And that's understood to be a 2 here. This part, this number goes to the denominator. This exponent goes to the numerator. Okay? So that 13 is in the numerator on that one. The next option we have 1 over p fifth root of p. Well, let's focus in on the bottom part there. We'll just leave this under a 1 over there. That would be p to the 1 times p to the 1/5, right? Converting that radical to an exponent function would be p to the 1/5. When you're multiplying like bases, what do you do with the exponents? When you're multiplying like bases, you don't multiply the exponents, you add them. So that means that this is going to become 1 over p to the 5/5 plus 1/5. Remember, 1 is 5/5, right? I converted to a common denominator so I could add them, which means this is going to become 1 over p to the 6/5, which is the negative 6/5. On the bottom, it becomes positive. So this does match up with our original. Does that make sense? So that's why this one did match up. The last one, it has a negative 6 on the, the last one has a negative 1 on the P and a 10 on the, so that last one, P to the negative 1 and a 10, that would become P to the negative 1/10, which is definitely not equal to the 5/6, the 6/5, right? So that's why those two were the only ones